Custom sort string. You are given two strings, order and s. All the characters of order are unique and were sorted in some custom order previously. Permute the characters of s so that they match the order that order was sorted. More specifically, if a character x occurs before a character y in order, then x should occur before y in the permuted string. Return any permutation of s that satisfies this problem. Okay, so we have, for example, here we have the order string, which is CBA, and we have the s string, which is ABCD. Our goal is basically just take the s string and take all the characters from s that appear in order and return s so that those characters that appear in order are ordered accordingly in s. But we're just returning the s string but like modified so that, so for example, it's CBA here, then in s it should be C, B, and A should be in the same order as is in order, right? So CBA, but we don't care about D because D doesn't appear in order, so that's unordered. It's considered an unordered character because we don't really, it doesn't matter where it appears, so we can just append it to the end. All we care about is that ABC is in the correct order, so it's CBAD, right? So it's like a subsequence, if you can think about it like that. Like the subsequence has to fit order. Like in example 2, we have orders B, C, A, F, G, and S is A, B, C, D. So from A, B, C, D, we see that A, B, C, all three of these again appear in order, but D doesn't. So these are three that we need sorted. Oh, let's see what appears first. Okay, B appears first, so B, and then we have C, so C, and then we have A, right? Just BCA, so then A, and then we just add D to the end because those are the ones we care about. So basically, a good way to solve this problem, in my opinion, is using an algorithm where, okay, let's just take a look at order first instead of bothering with S, right? We're going to do this in two parts. The first part is look at order, okay? And what we're going to do is if order is inside S, right? We're going to turn S into like a dictionary. It'll keep track of all its keys, which are all the characters and how many times the characters occur. If order, it happens inside of S, then we're going to add that to a string, right? We're going to loop through order, and if we see that it happened in S, then we're going to add that same amount of occurrences that happened in S to that string, okay? So then we know that all the things from order are now part of the string. But during that loop, what we're also going to be doing is every time we find something from order that happens in S, we're going to delete that character from the S dictionary. We're going to get rid of it. So then by the end of the loop, we're going to be, that dictionary will pretty much only have characters that are not part of the order, right? They don't care. It doesn't matter if they're ordered or not. And then, so for those characters, we're going to loop through the dictionary in the second part, or run another for loop through that dictionary, which now only has unordered characters, and just append to the end. It's like every character will just append that to the end of our answer string, and then our answer string will have the final answer. Okay. What does that look like, right? So first thing we can do is, so like if we say S frequency is basically the counter of S, okay, and we can have an answer string. So for I in order, okay, if I is in S frequency, then what we want to do is just answer plus equals to in here, right? S frequency of I, which is the amount of times it happens, times the actual character. Okay. So now here's okay. So you know what else we're gonna have to do? We're also, the next part, remember I said we're gonna have to delete. So now we're gonna delete S frequency of I. We're gonna get rid of that character now from our dictionary. Okay. Next, we'll loop through S frequency, and we're gonna append to answer S frequency of Y times Y, and this is just the amount of times that character occurs times the actual character. So it's just, that would just, like, if this was 2, because we saw that the character occurs twice, and the character is like A, for example, then this would be like AA. It would just be like that repeated twice. And now we can finish turn answer. Okay, so our runtime complexity here is O of n. We're going through both order, and we're going through S frequency, which is a dictionary that was created using S. So those are both O of n, runtime complexity. And our extra space is also O of n, because we created a dictionary using the input string S. And in the worst case, S could be all unique characters. So then S frequency would be fully filled. Like there would be just as many keys as there are characters in S. So yeah, in the worst case, that would also be O of n, extra space complexity. All right, thank you for